Okay, so in this video we're going to go over function compositions. Now, with functions we can do so operations that are kind of similar to real numbers are, let's say we have a function f and g. We can add two functions. We can subtract them. We can multiply them. And we can even divide them. Right, so these are kind of operations of two functions, right, that are equivalent, similar to the operations we have of real numbers. All right, now, as it turns out here, there's another function that another type of operation that is not like the, that is not something that we do with real numbers. It's kind of specific to functions, and that's what's called a composition. Let's see a little. Give me a second. Blurry. Okay. Okay, that's a little better here. Okay, so a function composition. So first of all, the notation. It's almost like a function nested inside another function. So the notation that we'll see is something that looks like this. Alternatively, it's use also this notation, right? The way we read this is f of g of x. Right. Okay, so we see here, we have our notation f of g of x, right? This is denoted by this open circle here. Now, again, this is different than this multiplication of functions. All right, this is this brand new operation that we're defining, right? So the way this works is that the function now takes as input the output of g. All right, so here, let me write that down here. So here the output of g of x is the input of f. All right, so let's kind of work through an example to see how this works. So for this example, let f of x equal to negative 3x minus 2 and g of x to equal to x minus 1. So we want to find g of f of x. So let's do f of g of x. Okay, so the way you would do this is you say, all right, so start by, again, we're not multiplying, right? So resist the urge to multiply them. That is incorrect, right? This is not multiplication. This is a brand new operation that we're defining specific for functions. So the way you would interpret this is, well, really substitution, right? There are going to be two substitutions. The first one being, well, let me substitute g of x. So we have f of x minus 1. All right, now how do I deal with this is now for the input of f, I'm going to replace here wherever I see an x, I'm going to replace it by x minus 1. So here I'll have negative 3, and in place of x, this whole expression goes in there. All right. I know I don't want to leave it like this. I want to distribute and combine any like terms. Negative 3x plus 3 minus 2. Negative 3x plus 1. Okay. All right. Again, be careful with your distribution there. So that's how you would do f of g of x. Now let's see the reverse. See if anything changes. How about g of f of x. Okay, so here we see this. We again start with the inner substitution, f of x. So g, right? And now wherever you see x, you replace it by this whole quantity. Combine like terms, there's no distribution to be done here, so we get minus 2 minus 1. And then we get this value. Okay, now one thing to pay attention to here is that f of g of x does not equal to g of f of x. Okay, so it's not equal for this particular example, so we can't really expect it to hold for really any example that we do, right? So what we can say at this point is that the composition of functions is not commutative. In other words, the order matters, right? It matters which one I do first. Okay? All right, now let's take a look at an example where we'll evaluate composition of functions. Now let's do that. The first example we're going to take a look at is one that involves a table. Okay, so here we have this table, and here we ask evaluating a composition function, a composite function using a table. So here we have a table of values. Here are input values and then the function values for f of x and g of x respectively. So I want to use this table to evaluate these two quantities, f of g of 1 and g of f of 4. All right, let's start with this one. So f of g of 1. Okay, so again, let's start by the inner one. Now, instead of substituting a whole function value, we just need the output here of x is equal to 1 for g. So for that output, we would get 3. Right, so replace with 3, right? And now simply evaluate the function for input value of 3 for f, and then that equals to 3, right? So again, first we start off, that is our output for our inner function of the composition, and now that becomes the input for f, right? And then the output there is 3. Okay, so now let's try the next one. All right, so for the next one, we want to find g of f of 4. Okay, so again, we start off for the value of 4, the input here, and the output for f is 1. All right, so we go to 1, and then we go, all right, what is the output for g? And that is 3. Okay, all right. And that is how we would go about solving something like this, giving a table of values. All right. Now, what if we just had two functions and we want to evaluate equations, essentially? Not, we have two functions and we're giving the rule, the equation. All right, so for example, given f of t is equal to t squared minus t, and h of x is equal to 3x plus 2. Find h f of 2. All right. Okay. So the way we would approach this is we'll start again with our inner function, f of 2. So given f, plug in 2. Now the h doesn't go away, it's still out here. We'll plug in 2 wherever we see a value of t here. Okay, so that's h of 4 minus 2, h of 2. And now we go with our outer function h and plug in a value for 2. So we get 6 plus 2 That is 8. And that is h of f of 2. All right. Okay. Now, one thing to notice here is once I plug in the value of 2 into f, the f is no longer there, right? I've substituted into the function. All right. Notice here the same thing for once I put h into the 2 into the value for h, that there's no h of. It's just 3 times 2 plus 2. Okay. All right. Let's do one more to wrap this up here. All right. So same functions here, but now I want to evaluate h f of negative 2. Okay, and then here we plug in negative 2 into h. All right, and we add here, we got h of 6, and 3. 6 times 3 is 18, plus 2 is 20. All right, so again, think of this as one layer of time. You start on the inside, you do one at a time, right? Once you're done evaluating, then you'll work your way outside to the next layer. All right, thank you.